Now, yes, please take these notes down. So, now we're talking about, as we go through experimental and theoretical, we also, when we look at probability, we'll look at something called a tree diagram to help us understand the total number of possible outcomes and a particular event happening. It'll be able to be a picture instead of just kind of in our mind. So in this particular case, the tree diagram is to show the total number of possible outcomes in a probability experiment. So this example, we're going to flip one coin 3 times. So, let me kind of explain to you what the tree diagram looks like here. So the first coin is flipped. You can either have a what? Heads or tails. Now, if we're doing it as a not individual, so if we flip the coin later, then that would kind of be an individual event. That would also be 50%. But what we're trying to figure out is if we flip the coin 3 times, how many times what is the probability of a heads, heads, heads? Well, let's take a look. If we flipped it a second time, we flipped the coin a second coin. Okay, we flipped it the second time. So now we have, from a heads, we go, and we have a heads, heads. We have the first one heads, the second one is tails. We had a tails, heads, and we had a tails, tails. What is the probability of, if I flip the coin twice, of it being tails, tails? 1/4. See how there's 4 possible outcomes on that?
Yeah.
What's the probability of being heads, heads? 1/4. What's the probability of one head, one tail? 1/2. Very good. Now, if I wanted the exact order to be important, if I wanted it to be a heads, then a tails, then I'd have what? 1/4, and a tails and a heads, it would be. You need to make sure all possible outcomes equal what? 1. 1/2, or 1/4, a 1/4, a 1/4, a 1/4 is 1. Or a 1/4 and a 1/4 and a 1/2 is 1. 1/2 and a 1/2 is 1. Okay, so you would never be able to have that possibility or something occurring if there's an outcome out there that's not really possible. Then it's not really a pure probability or experiment. Okay, like flipping a coin, heads or tails, and then we have the side as one of them. That's not going to be possible. Okay, so that would be a 0% chance. Now, if we did a third coin now, so we did a third coin, so these are our possible outcomes. Heads, 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 tails. Heads, tails, heads, tails, heads. Heads, tails, 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 heads, heads. Tails, heads, head, tails. Tails, tails, heads, tails, tails, tails. Okay? Now, let me go back through that. Now, I said it really fast, I understand that. But look at the possible outcomes that could be there. Okay? Now, if I did, what is the probability of having 3 heads? Yes. 1/8. It's actually 1/8 for every one of these in order, correct? Now, my question to you, Crabtree, is what is the probability of having 2 heads only in any order? Well, let's look at that. 2 heads. Heads, heads, tails. Does that work? Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. No. So what's the probability here? Now, if we looked at it, just thought logically, what is the probability, Jacob, of 2 tails? And only 2 tails. If 2 heads was 3/8, 2 tails would be? No, 3/8. remember, there's a 50% chance of both of it happening. So 2 tails would also be 3/8. Okay? What's that? Okay. Okay, that would be the other one. That would be the 1/8 here and the 1/8 here. So that would be your difference. Okay? Because remember, the one that only has 1 tail heads is actually the one that has 2 tails. Okay? All right. Yes. Okay. Why am I not going in? There you go. Okay. Now, let me ask you here. As an example, this will be similar to our homework tonight. Okay? We have 3 flavors of ice cream and 3 toppings. Okay? 3 flavors and 3 toppings. One of them is, so the three flavors, vanilla, chocolate, and strawberry. The 3 toppings are Oreo, Heath, and Skittles. Okay? Now, some of you might not like Skittles on your... some of you do. So, my question to you... Now, hold on. Our 3 flavors again are what? Vanilla, chocolate, and strawberry. Now, for each topping could go on to here. So, for vanilla, we would have what? Oreo, Heath, and Skittles. So, now, hold on. Shh. We're saying you have to have a topping here. So, your other one would be here would be Oreo and Skittles. Or you could have Oreo and Skittles. So my question to you is, how many possible ice cream sundaes can you have? How many are you thinking? 9. That is correct. And you can do it by this. You have 3 choices here and 3 choices there. That would be 9. But if you counted them up, that would be your tree diagram. This is very similar to one that you're going to do tonight, maybe exactly, on your homework. Okay? So that would be 9. Now, my question to you is this, Ellie. What happens if I said that you could also make 0 or no topping? You would actually have 4 choices, right? Because then you would have one up here that said none, none, and none, and that would be 12. Okay? So if you wanted to do that. What's that? Well, we didn't say that. Now, there's a lot of variables that can happen if you said, well, you can have more than one topping. But for our particular problem today, we only said on 1. Okay, that's going to be the number 1 question on your homework here. We're going to do this and we'll take it for a grade here in a second. Or I'll get your grades on your homework here in a second.